Hi everyone, this is my sister Taylor. She's going to help us demonstrate how we can teach our students how to find the area of shapes during our geometry units. So Taylor, the first thing I'm going to ask you to do is how can you make sure that the end of your strip is perpendicular to the length of your strip? So the first thing Taylor did was she folded this strip in half. So now there's a crease here and she's showing that the length is perpendicular to that crease. Thank you so much, Taylor. All right, how can you get a fold line that is parallel to the edges of your strips?
Fold it the other way.
So Taylor took the rectangle and she folded it down the middle to show that it's parallel. She made a line that's parallel to the edges. All right, so now that we've worked a little bit with parallel and perpendicular, we're going to move on to rectangles and parallelograms. So the first thing that we're going to do is you're going to start with this rectangle here, and I'm going to ask you to consider how many different ways can you make one cut on that rectangle and turn it into a non-rectangular parallelogram. So how can you cut it to make it a parallelogram in just one cut? And you may use the scissors to do this. You know what to do.
It's not going to be even.
That's okay. Just think, just one cut. Okay, so Taylor cut the rectangle with a diagonal line. So now show us, or show me, how you can make a parallelogram with those two shapes.
Uh-oh.
It's okay. Keep working with it. There's a way to do it. Yep.
Oh, okay.
It's a little uneven, but that is good. So Taylor, with a little bit of guidance, found that when you flip them so that the trapezoids are opposite, you can create a parallelogram. So now we have a parallelogram. Now I want you to think. I'm going to give you this circle, and while I'm creating this, I want you to think about how you could cut this circle. I want you to cut a diagonal line across it with the scissors. You gotta hold it in the middle so that it stays. And then go ahead and cut it diagonally. Taylor's left-handed, only one in the family.
Okay.
Just as much of a diagonal line as you can, I guess. This will be interesting. Maybe just cut it down the middle and just see what happens.
Can you hold it?
Don't cut my fingers.
Uh-oh.
All right, so Taylor has cut that circle for us, and they've created parallelograms. That activity is a little hard. I don't know if I'd recommend using that one. But it is a good way for your students to see the relationship of cutting the edges without starting with a direct shape that they know. So we're going to go back to the parallelogram that we have on the table. So how many places could you cut a parallelogram to form a rectangle?
Do I do it?
No, you don't have to do it for this one because you've already cut it, because you have a parallelogram. So how many, or if you could cut it, how would you cut it to make a rectangle?
I'd cut that out and then flip them.
So Taylor said she would, if this were still one shape, that she would cut from the vertex up here down so that she makes a triangle over here, and then she'd cut from this vertex up to here, and then she'd flip the triangles to make it a rectangle. Are there any other ways that you could think of to make a rectangle from that?
By cutting it?
Mm-hmm.
No.
Okay, that's okay. So the one other thing that you could do is you could just cut off this and then just slide that
over
piece
here.
over. Mm-hmm. Or you could cut it in half like it's already cut, and you can turn them, and that makes a rectangle. So, do you think there are a finite number of ways to cut parallelograms to turn into rectangles, or an infinite amount of ways?
Infinite.
Infinite. But what are the conditions then? If there are an infinite number of ways to cut it, if starting from here, you would either have to cut them this way or this way, correct?
Yeah.
Yeah. So then, what are the conditions for it being infinite? For it being an infinite number of ways to cut it?
They have to be straight lines.
They do have to be straight lines. And then what were we working on earlier?
Oh, folded?
No. What's the words on it?
Oh, perpendicular and parallel.
Yeah. So they either have to be perpendicular
Oh.
or parallel to the lines that are already created. So now I want you to think about a formula that you could create. Since you already know that the area of a rectangle is
The base times height.
base times the height. So since you know that, using this, what is the area for a parallelogram?
Base times height.
And how do you know that?
Because a parallelogram is still a rectangle, just in a different form.
Mm-hmm. So you never took anything away. And what two things stayed, or what stayed the same?
The height.
Mm-hmm. And then the base is the same length, just switched around. So now we're going to move on to triangles. So we're going to begin with these two triangles. And what I'm going to ask you to do is there any way you can take these two triangles and form a parallelogram with them?
Uh-oh.
Awesome. So Taylor took these two triangles and she put them together like this to create a parallelogram. So, looking at this parallelogram in front of you, can you derive a formula for a triangle, since you now know the formula of a parallelogram?
Base times height divided by 2.
Mm-hmm. Perfect. So, now you're going to take, we'll use this triangle, and this triangle, and I want you to, or actually, let's use a little bit bigger ones, it'll be easier to fold. So I want you, this one will just be for comparison, and so I want you to take this one and I want you to fold it so that you create a height line.
Oh.
That's okay. If you want to fold the other one, you can, and just use that one for comparison. Awesome. And then I want you to take the top vertex of where the height ends and pull it all the way down to the base and then fold it. Mm-hmm. Perfect. Go ahead and unfold it, and then I want you to cut off that triangle that you created at the top. And then I want you to cut the triangle in half on that crease line. Some big scissors. Okay, so then I want you to see if there's a way to use those two triangles to make that a rectangle.
Evenly? Or?
Close enough to a rectangle. Thank you. So Taylor arranged these shapes. She put the rectangles at the corners to make it a rectangle. Thank you. I mean the triangles at the corners to make it a rectangle. So, looking at this rectangle now and comparing it to the triangle, because I gave you two congruent triangles and then you cut one of them. So comparing these to each other, how do you know that the rectangle and the triangle have the same area?
Because I never took any of the pieces away.
Good. And then how do the bases of the triangle and the rectangle compare?
They're the same.
Correct. And how does the height of the rectangle compare to the height of the triangle?
It's half.
And then can you write a formula for the rectangle using the dimensions, the height and the base of the triangle?
Isn't it just base times height?
So our bases stayed the same, but what happened to our height?
Oh, base times height times 2. Divided by 2?
Divided by 2, there you go. All right, so then we're going to go on to another triangle activity using these two triangles. They're also congruent triangles. So what you're going to do is you're going to make that height fold again, or here, we'll go like this. Go ahead and make the height fold on that one. And then I'm going to have you take the outer corners and fold them into the height line. Yep. And then go ahead and unfold that. And then I'd like you to cut off those outer triangles that you created. Then using those, that's okay. Using those pieces, try and create a shape that you recognize using those pieces.
Any shape?
It might help if we make the cuts a little bit cleaner just so that you can see.
Of course it works for you.
So try and create a shape that you recognize. And it's going to be a little uneven because it's not always perfect. But yes, so Taylor used the shapes that she had. She put them in the corners up here and created a square with both of those triangles. So now that you have a square and you have this triangle, how do you know that the rectangle, or the square, and the triangle have the same area?
Because it never took anything away.
Good. How do the height of the triangle and the rectangle compare?
They're the same.
And how does the base of the rectangle compare in length to the base of the triangle?
It's half.
So, can you write a formula for the rectangle's area relating it to the triangle? So using
Base
the height.
times height divided by 2.
Do you divide the entire thing by 2?
Height times base divided by 2.
There you go. Good job. So, we just created 3 formulas for triangles. Do you think all of them are equal to each other? Do you think they all give you the same values?
Like number-wise or?
Number-wise, yeah.
No.
No. Why do you think no?
Well, they weren't the same size triangles.
But if we just derived a formula from it. So if I use that formula and I use it all on the same triangles, like all
Oh, but
three of
does it
these-
matter what number?
No, yeah, it doesn't matter
Oh,
what
same.
number. Yeah, okay. So sorry if that was weird wording on my part. So yeah, so all the formulas will give you the same answer. Do you think that there would be a time when one form would be easier to use than another? Like think about if you were given one of these values.
Well, wait. Well, it depends on whether or not you're, like, with this one, the height was divided by 2. Or yeah. But for this one, it was the same. And then that one was multiplied by 2.
Yeah.
So it depends on what you're trying to figure out.
Yeah, awesome. Now we're gonna move on to trapezoids. Fun, fun, fun. So, I'm gonna give you a parallelogram and a rectangle. I want you to look at those and using one cut, make a trapezoid. One cut on both of them. How can you make a trapezoid?
2 trapezoids or just one full one?
One trapezoid created from a cut on this, and one trapezoid created
Oh.
from a cut on that. So separately.
Right. I'm not actually gonna cut it. I'm just looking. What does a trapezoid look like? Is that one where it's...
I think
This.
so. I couldn't really tell. It looks like this.
Oh.
Or it can. I think were you doing where it does like this and then on like that?
Where it has, you could square 2 triangles.
Yeah, yeah. So it can be either of those. Those are both trapezoids.
Why can't I just make one big one?
Wait, you mean like taking two, combining these?
Yeah.
No, don't combine them. Just making one cut on a parallelogram. How can you make a trapezoid?
Can I?
Huh? Try making a parallel cut, or a diagonal cut.
Uh-oh.
Go ahead, yeah. I mean, we'll just see what it gets you. All right. So Taylor cut it right down the middle. So, and you can kind of arrange those to make, yeah, you can do that too. That's smart.
That doesn't look good.
So Taylor cut the parallelogram down the middle and then rearranged them so that it goes like that to give you a parallelogram. So, and then is there a way that you could cut the rectangle to give you oh, that's a parallelogram. Can you make a trapezoid? That's what I meant to say.
What's a trapezoid?
It's this one.
Thought you said that was that one.
What was one?
That was that one.
No, that was a parallelogram.
Well, we need a right angle. And we need a diagonal. If I cut it, do I have to use the piece I cut off?
Mm-hmm. It is possible to do it with the rectangle. I know it's possible to do it with the parallelogram too, but I can't remember. Think about.
Wait.
Okay,
Can I cut it here?
if you'd like, yeah.
It's gonna rip.
I know. I know what you were trying to do. You have to use further back. Oh, okay.
That worked well.
Yeah. If you would have done it yes, that would have worked. Think about what a trapezoid looks like.
I need a right angle, but it needs to be small on top, so I need to flip it. That's all I need.
Okay, yeah, so that is a trapezoid, but the other way you can make it is going like that, and if your cut would have been right, it would have created it. So,
Well,
Taylor did identify that when she made her cut, if our scissors were a little bit better, that it does create a trapezoid, and then if you take the piece that you cut off and put it on the other end, it makes the trapezoid. So, we have a trapezoid now. Lovely, lovely. So, now we have 2 congruent trapezoids that are already pre-cut, so you don't have to worry about it. So can you use 2 congruent trapezoids to create a parallelogram? And if so, can you show us?
do I have to cut it?
Beautiful.
That's not a parallelogram, that's a rectangle.
You're right. Awesome. So Taylor took the 2 trapezoids and put them together like this to make a parallelogram. So the base of this parallelogram is base 1.
Okay.
And this base is base 2.
Okay.
And remember, this one is just flipped.
Yeah.
So, knowing that that's base 1 and this is base 2, can you give me the area of this parallelogram?
Base 1 plus base 2 times the height.
Mm-hmm. And then so that gives me the area of the parallelogram, and then if I just wanted to find one of the trapezoids, what would I do to that formula?
Divide by 2.
Correct. So the entire formula would be base 1 plus base 2 times height divided by 2. All right. Now I'm going to ask you to look at these and then cut one of them in the middle like this. Try and make it parallel. If you can use this one, it's okay.
What do you mean?
Oh, that is parallel. It just looked weird from the way that I was viewing it.
Dang, I was doing good.
That's okay. All right. So then using those two pieces, can you make a rectangle?
Uh-oh. What?
First, I don't know. I think it's because you didn't cut it right in the middle.
That was right in the middle.
I don't know what happened.
Oh.
It's supposed to go like that.
Just a little uneven.
Okay, so with a little bit of help, Taylor found that when you put them together like this, it creates a rectangle. It's a little bit uneven, but a rectangle nonetheless.
Well, I did that. It was just like this.
Okay, so how do you know that the rectangle and the trapezoid are the same area?
Because they were the same shape to start with, and I never took anything away.
Perfect. So, can you give me an area formula for this rectangle if this is base 1 and this is base 2?
Base 1. Base 1 plus base 2
Yes.
times 2. I don't know.
So what's the formula for a rectangle?
Base times height.
Okay, so we found the base 1 plus base 2. What happened to the height?
Got divided by 2.
So what's the formula?
Base 1 times base times height divided by 2.
So what, and then what
base
is...
1 plus 2, base 2 divided
Yep.
by 2.
Do you divide the bases by 2 or the height by 2?
The height.
Yeah, so it'd be base 1 plus base 2 times...
Divided by...
Oh yeah, or you could do that.
What?
So when we find the area of a rectangle, you take the base times the height, right?
Mm-hmm.
So we know the base is base 1 plus base 2.
Yeah.
We're saying that this is half of the height.
Yeah.
So half of the height times...
Base 1 plus base 2.
Yes, so that is the area for the trapezoid. All right. Now we're going to move on to our last one, the circle. So, I want you to fold it into eighths, and I'm going to get you a marker to highlight the radius. So go ahead and fold it into eighths. So go ahead and just trace one of the radiuses with that marker.
Ooh, that was uneven.
You might want to try folding it one more time just to make it that way when you cut it it'll work out.
Oh no, that's not what I meant to do. I meant to do this. Oh my god. You have another circle?
No, it's okay. So
I'll just trace it. I know what I
you got it? Okay. So go ahead and trace maybe one of the ones that I already have with the brown marker. And make it like thick enough that you'd be able to see it because you're gonna cut it. Okay. Alright, perfect. So now cut out, honestly, if you just want to cut it out those and then cut them in half. So you have 8 pieces. So cut on my lines. Yeah. and then cut these in half. And then that'll give you eighths. Okay. Keep doing that. If you, yeah, you'll just have to cut kind of quick. Yeah, try and make it a big cut. Yeah, there you go.
That did not do much better
That,
than the last time.
yeah, it kind of did. All right.
I created a triangle that I can cut in half.
All right. So now that we have 8 pieces, I want you to try and take those pieces and make something that's similar to a parallelogram or a rectangle.
That's not right. That's gonna take too long.
You don't have to cut anything else. You can just use those pieces and make a rectangle.
Oh yeah, there you go. That's a rectangle.
So I'll
Wait. That's a no, that's not. Well, it can be.
It's you're getting closer.
And then
So
just do the same thing. Uh-oh.
did you see what you almost just did? Look at 2 of the pieces. There are 2 pieces that make an almost rectangular shape, but they aren't close enough together yet.
Oh.
Okay. Now use all of the pieces. What would happen if I turned it like this?
Oh, I'm stupid. I knew about
No, you're
this.
not. You're not.
Plus, I knew I could do this. I just didn't think.
That's okay. We did this in class, and I
Yeah,
I
we
didn't
did
get it
this
right
in
away.
class like 3 weeks ago.
Okay, so what Taylor did was she took all of these pieces. I'm just gonna move the camera, and she laid them out like that, so that they make a shape that resembles a rectangle or a parallelogram. So we know that circumference is pi times 2 times, or the radius times 2. So pi times the radius times 2,
Diameter.
or the diameter. So pi times diameter. So you know that that's the circumference. So looking at this, what could we say our height is?
The radius,
And what could we say our base is?
the diameter.
Remember, the diameter is the radius times 2.
Oh,
The circumference is that outer part of the circle.
circumference.
So what is our base? How much of the circumference do we have?
4.
Which is,
4 times radius.
so yes, but so if we have, how many total pieces of the circumference
8.
do we have? So we have 4 on the bottom,
4/8.
which is, simplify it,
2/4,
which is,
which is 1/2.
so we have half of the circumference times the radius. And that gives us the area, right?
Yeah.
All right. So half of the circumference is 2 pi r.
Okay.
So we can take that and divide it by 2
Yeah. To get the diameter.
to,
You said 2 times r times pi. And
yes.
r is radius and r
Yes.
times 2 is diameter. The diameter times pi is circumference.
That'll, okay, I'm gonna ask you some questions. We'll get back to that. So, how do you know the circle and the parallelogram have the same area?
Because I never took anything away.
Okay, what's the height of the parallelogram right there?
Radius.
What's the base?
Half of the something.
What's the outer part of it called?
The circumference.
Half the circumference. So, our formula could be pi times r, which gives us the half of the circumference, right?
Yeah.
Pi times r. times the radius. Because that's our
our
height.
radius.
Mhm.
So
So pi r is half of our circumference.
yeah.
And then we have an extra radius.
Okay.
So we're multiplying pi r by r.
Okay.
What would happen if you multiply r by r?
You get not diameter.
Just if I
Circumference.
if I did this, if I wrote r times r, what does it equal?
R2. 2R.
Is that 2r?
Yes.
Or is there a different way that we write it when we multiply variables like that? Think about what's the area of a circle?
Huh?
What's the area of a circle?
Diameter times pi.
So diameter is also 2r, right?
Yeah.
So if we're taking r times pi r,
Pi times R.
because this is half of our circumference,
Yeah.
so that's our base, and then radius is our height.
Yeah.
So height times base. So r times pi r. So when you take the radius times the radius, when we multiply those two things together, we have to square it. So r times r becomes r squared.
Isn't that?
Someone's home. That's okay.
Isn't that? No, that's a. No, what is that called?
An
The
exponent.
2th power, the 2nd power.
Second power.
R
Yeah,
to the
raised to
second
second
power.
power.
Yeah.
So that's what happens here. So then what would this look like? It would equal
R2 pi R2
pi r squared.
Okay.
Awesome. So, thank you for helping us show how to find the area of all of these shapes. We
Yep.
should probably practice a little bit more. Bye, guys.